Hi everyone, welcome to my channel. I'm going to discuss the topic electrical and simple electronic diagrams for week 13 for automation 1. So in your topic, it says discuss the process and instrument diagrams of automation system based on the industry standards. So in here you have the STCW function which is taken from STCW table of competence. So just read this STCW function that can proceed. So electrical and simple electronic diagrams, we had the uh, learning objectives. Explain major electrical and electronic symbols used in their circuit diagrams. So we have another learning objectives, interpret, process, and instrument diagrams of automation system based on the industry standard. So let us come in the piping and instrumentation diagrams. So we have here the what we call the P and ID information. So we have the component identification, how instruments are connected, where instruments are located, and function within the process. So we have also here the P and IDOs for troubleshooting, process monitoring, and we have also here the heat exchanger, which is the machine. And we will compare it into our instrumentation diagram. So as you can see in here, uh, your heat exchanger here in the uh, machine, we are comparing your heat exchanger machine into our instrumentation diagram, which is this one is the heat exchanger and this one. So we are now we run this what we call the heat exchanger, and we also familiarize here in the diagram. So as you can see, this is your what we call the IP transducer, which is connected to your uh, actuator, which is steam control valve. And your actuator uh, is there is also here the symbol. So this one, your actuator, steam control valve, which is the equivalent here, the TV 401. This is your actuator. And your controller is your TIC 401. So we'll uh, continue this uh, video. So as you can see, your what we call the valve, the steam control valve is highlighted here. Equivalent in your diagram is the TV401. So that one. So as the your machine is working, the equivalent component in your diagram is also highlighted. So let's take a look. So this is your transducer, TT41 is your transducer. So this is how to understand the diagram in comparing to the diagram of the machine. That is your transducer TT401. So it sends signals from your thermal sensor, as you can see on that uh, the highlighted component, the highlighted uh, pipeline, and highlighted transmitter. So TT401 is a transmitter. So as you can see, your controller TIC401 and your transmitter. So from your thermal sensor, which is depicted here, the temperature sends to your thermal sensor, and your thermal sensor send feedback signal to your controller, and your controller also sends signal uh, uh, to the IP transducer. Then it sends also signal to your actuator. So as you can see now, send signals, and then your controller, which is TIC401, as you can see, send signals to your IP transducer, which is this one, and the equivalent to your diagram is TY401. So we will see what will happen now. So your IP transducer is highlighted in the diagram. So that is your IP transducer. So your IP transducer will send also electrical energy to your actuator, which is your steam control valve. So from your steam control valve, so now your steam control valve is working. So in the diagram, so that is your actuator in the diagram. So it pushes the the what we call uh, the linkage or the rod into the bulb inside, so the flap. So it opens or close the bulb using your actuator, which is your steam control valve. So let us come with your it says here in your topic, uh, discuss the process and instrument diagrams of automation. So I'll be using an electro hydraulic uh, diagram, a ladder diagram with the steering gear. So first you have here the diagram of your steering gear. This one here. And here is the diagram of your electrical system. So which is controlled by which is powered by 24 volts. So in here in your diagram, you have here the uh, push button switch or the big brick switch. You have the LE stop or limit switch number 2, this one. And here you have the relay 1, and the solenoid valve. So your solenoid valve E1 is the port side here, and your solenoid valve number 2, which is K2, is the starboard side located. So you have also here the hydraulic cylinder. You have the LS1, which is uh, limit switch 1, and LS2 limit switch 2. So you have also here, so in the system here, electrical system, you have the buzzer and the indicator light. So, and here you have the power pack, the motor and the hydraulic tank with the hydraulic oil. Here is your valve lock, uh, solenoid valve. So we will now simulate. So what will happen in here? We will move our piston into starboard side. So we will move this one there. No, so I will try. So, starboard side. So now your so as you can see, when I push the push button to the for the starboard side, your piston is moving to the starboard side. So uh, the circuit, so the I will press the port side now. So when I press the port side, the piston is moving to the port side. So I press again the starboard side. Press again starboard side. So this circuit here uh, is closed, and then your piston is moving to the starboard side. So uh, when I uh, push the port side, so now your line, the hydraulic line, the port side is uh, giving the hydraulic pressure to the port side, push the piston, and then your piston moving to the port side. So that is how the electrohydraulic steering gear is uh, working. So in here in the hydraulic system, when you when I push the port side uh, push button, so your uh, key one here is activated. Your solenoid valve is activated and opening the port uh, so that the hydraulic oil can pass to the port side uh, pipeline to push the piston the port side. So when I uh, press also the push button switch uh, the starboard side, so now the starboard side in the hydraulic system, the starboard side uh, pipeline, the pressure line, giving pressure, hydraulic pressure to your uh, hydraulic cylinder, and it is pushing the what we call the piston to the starboard side. So this is how connected your electrical circuit to your hydraulic system. So your electrical system uh, is connected to your hydraulic system. So that you can operate uh, remotely on the bridge. So on the ship, the deck department, the deck officers, they operate on the bridge, the steering, so they can operate there by means of the uh, electronic and electrical system because it sends electrical uh, signal to the solenoid or electrical uh, energy to the solenoid to operate the solenoid valve. So this uh, hydraulic power pack is continuous running with circulation. Here like this, circulation. So when the valve is operated, so it is the pressure of the hydraulic is going to the hydraulic cylinder, and here the hydraulic cylinder, if there is a rudder in here, so the rudder is moving to port, hard port, hard starboard, and to midship by the use of the hydraulic, so hydraulic pressure. So that is the explanation how the electrohydraulic steering gear works. So by operating the uh, electrical mechanism, so the hydraulic mechanism is also working because they are uh, uh, interconnected system. We operate the hydraulic system by the use of the electrical system. So I simulate again. So here I push the uh, port side push button. So piston is moving to the port side, and I operate again the starboard side. So the piston is moving to the starboard side. So that is the explanation, the process, the instrument uh, diagrams of automation system, and I simulated to you how it is working. So uh, I stop this simulation. I proceed to uh, the next discussion. So let us come with another example. So I give you an example here, which is refrigeration system. So in here you have the cooling motor, the blower, and here you have the compressor. So compressor motor is for the to drive the compressor. So how this two motors or the power circuit is operated. So we have also here the control circuit. So your control circuit is either 24 volts or 110 volts. So here in your control circuit, so you have here the stop switch, you have the start switch for uh, cooling fan motor, and you have the contactor for the cooling fan motor. And here, so this is your contactor, your relay. And here in the your CTO, we have also here the push button switch or the start switch for the compressor motor. So and you have the contactor, which is CTO. And uh, here are your uh, relay C1, C2. So this one for the stop button for the uh, contactor to. This one for the stop uh, stop indication for the contactor to light indicator. And here uh, light indicator for one. So here also CTO uh, relay for the alarm. Now I'm uh, going to simulate. So you cannot start your compressor motor in refrigeration system and air conditioning without the without starting the cooling first. So I will show you. I will try. So you're gonna start because the circuit here in the uh, cooling fan motor is open. So there is no uh, continuity. So this is a open circuit. So you must first. So what is the consequence if you start allow the the compressor motor to start without the cooling? So remember your refrigeration system uh, is circulated. So your evaporator is there is a refrigerant passing there. So without the air, uh, it can cause a lot of ice. So it cannot be. Uh, you should uh, what we call start first the cooling motor, uh, the, the blower motor, so that there is an air passing to the pin through the evaporator, so that uh, the cooling effect of the what we call the refrigerant will transfer, or the will transfer to the air, will be absorbed by the air. So you need to start first the cooling. So I will simulate now. So this will start because your circuit here, when you start this one, will be closed. So allowing the travel of electricity. So I will start now your cooling. So as you can see, uh, your blower motor, cooling fan motor uh, is running because the circuit now is. So the purpose of this start push button is to just give uh, quick connection of the uh, electrical power here. So to give a contact to activate the coil, the starting coil, so that this contactor will close the circuit, allowing the current to flow. So now the circuit is uh, uh, closed. So your blower motor or the cooling fan motor is working. So now you can start now your compressor motor. Start your compressor motor. So now your refrigeration system is working. So your motor is running now, the blower for the cooling, and also your compressor. So that is how uh, to control to start the refrigeration system by the use of this power circuit and control circuit. So if you want to stop, so I can stop in here. So this is stop push button, so I stop. So I open the circuit of the control system. So your contactors uh, will also open circuit. So, allowing to stop the system. So I will stop now. So as you can see, both compressor and cooling fan motor is stopped. But normally, our refrigeration system on board the ship, there are individual uh, what we call stop button and start button for the compressor as well as the uh, cooling fan motor or the blower. But here, this is just to simulate how the power circuit is controlled by the control circuit. So I start again. So as I said before, you cannot start your compressor without starting your cooling. So even if I try to start here, I cannot start because the circuit is open. So I should start first the cooling. So that is the system of the refrigeration system. So I start the cooling. So the cooling is starting cooling fan motor, the blower. So the circuit now is closed. You can see here and this one here. You see. So you just need to uh, start the push button of the compressor to close the circuit, allowing the electricity to flow. Now, so this is how your refrigeration system works. So I start this simulation now. So in here, this is uh, found in your lab manual exercise. So I have example here, explanation with the power circuit and the control circuit. So I use several examples, several system, uh, which is the heat exchanger, the electro-hydraulic steering gear, and the refrigeration system. So you have to watch carefully and take your notes, analyze. So in here, in your lab manual exercise, uh, you will be asked what will happen when the push button to express. So you just uh, refer to my explanation in the uh, electro-hydraulic steering gear. So it's the same uh, what we call the same system in here in your manual exercise. So here, discuss the process and instruments diagrams of automation system based on this industry standard. So I already discussed that one uh, a while ago. So here, you have the form of your lab manual exercise. So I already uploaded this one in your LMS, in your Binacle. So you have to download it and print. You have to uh, do your exercise in handwritten. Then you have to upload back to Binacle so that I can check. So this is the end of the discussion. Thank you for watching. Click like and share. Write a comment below. Don't forget to hit the subscribe button and the bell icon. Thank you for watching and see you on my next video discussion.